Alrighty, day 2 of geometry. Woo woo! Alright, so today we are just looking at something simple, pairs of lines in space and pairs of angles when you have two lines cut by a transversal. Alright, so lines in space, pretend these segments go on forever, that there's big arrows pointing out at the ends of them so that they're actually lines. So first up, parallel. Well, hopefully, since we just were graphing parallel lines, you will remember that parallel lines never cross. So there's lots of examples. The one I chose was line AC and line DB. So those would be parallel lines. But there's lots and lots of them here. BG and DI or DJ would be parallel lines. HJ and FG would be parallel lines, so lots and lots of choices. All right, so intersecting lines. Well, they have to have a point in common, a single point, one single point. So I said line CD and line DJ. They're going different directions, and the only point they have in common is D. Okay, coincident. This is kind of a weird word. Coincident, kind of like coincidental, but it's a coincidence. It happened at the same time, and it was just really weird. So they're the same line. So it's like I'm going to say graph line CE and graph line EH, but then when you go to graph them and look at them, they're actually in line together. So line CE and line CH end up actually being the same line. So those are called coincidence. Skew. Skew is a little bit different. It's basically they don't intersect and they're not parallel. So they're the opposite of both of these top ones together. They don't intersect and they're not parallel. So the example I gave was CD and JG. See, this one's on the top going left and right. This one's on the bottom going backwards and forwards, but they never actually touch each other, but they're going different directions. Okay, so those are called skew. So to give you another example, CA and FG are skew lines. Or maybe DJ and AB are skew lines. Okay, so they're not intersecting, but they're not parallel. They go different directions. All right, on to the one that we're really going to focus on and use a lot is two lines cut by a transversal. So we have two lines. A transversal is just a third line. Don't ask me why they can't just say cut by a third line. I don't know. Someone somewhere decided we're going to call this a transversal and confuse everybody. All right, so we have two lines cut by a third line. We get angles that are called corresponding. These are angles that are in the exact same position in this set of 4 and in this set of 4. So angle 1 and angle 5, they're both in the upper left. Angle 2 and angle 6, they're both upper right. Angle 4 and angle 8, they're both lower left. Angle 3 and angle 7, they're both lower right. So they have to be in the exact same position, and those are called corresponding. Okay, alternate interior angles. So alternate, meaning they're on opposite sides of the transversal. Interior, they are in between the two lines. So 2 and 8 are called AIA, or alternate interior angles. 3 and 5 are AIA, or alternate interior angles. Okay. Alternate exterior follows the same pattern, opposite sides of the transversal, but they have to be outside of the two lines. So angle 1 and angle 7 are alternate exterior angles, or AEA. Angle 4 and angle 6 are AEA. Our last type are called consecutive interior angles, or CIA, and then someone decided to change the name and make it same side interior, SSI. So these mean the same thing. Different books use CIA or SSI. I like SSI because to me it makes more sense, but I like CIA just because, it's the CIA. Alrighty, so That means they're in between the two lines, but on the same side of the transversal. So angle 2 and angle 5 are CIA. Angle 3 and angle 6 are CIA or SSI. All right, so that's it for this set of notes. See you in the next one.